Welcome to Yamuna's Physics. Today we have to find out the relation between R and F. Capital R, small f. You know the terminology? Capital R for radius of curvature, small f for focal length. So let's straight away come to the diagram. We have drawn the diagram for both concave mirror as well as a convex mirror. The same figure, same colors, same terms, exactly, just the differences. Here you have a concave mirror, here you have a convex mirror. We are going to explain it for the concave mirror, and the same thing applies for convex mirror also. Need not explain both. Okay, so we'll start. So you have a concave mirror here. Terms are very familiar to you, hope. Center of curvature, focal length or principal focus, this is focal length. Center of curvature, this is radius of curvature, termed like PF. PF means from P to F. PC means from P to C. Here again the same thing. P to F, focal length. P to C, radius of curvature. Clear? The pole is here. Center, geometric center of that mirror. This is the center of that sphere of which the mirror is a part. So it's a very big sphere, and you have taken only a small portion of that big sphere. Okay. Now, in the last video, we have discussed 4 rules. We have 4 rules or 4 rays specifically for image formation. Here we are using the first ray or first rule. Every time I use magenta shade for that, do remember that magenta color means a ray which is coming parallel to the principal axis after reflection goes through the principal focus. Come along, this is the way it comes, falls here, and this is the way it goes out, reflected through F. Okay? Now physics is over, the rest is geometrical optics, maths. Now, any ray which is passing through C will be, if you have a line from C to this mirror, any line from C to the mirror will be definitely its radius, because the name itself is radius of curvature, and the radius of curvature is always perpendicular to the sphere. So CP is a radius of curvature here. Again, CN will be also the radius, but not radius of curvature. You have to measure it from the pole. You can't measure it from another point. So all the measurements has to be from the pole. So this distance, the magnitude of CN is definitely radius of the sphere. That is radius of curvature. But here I have drawn it for the purpose of a normal. So always the radius is normal to the surface. So at the point N where the ray is coming and falling, at the point N, the normal is Cn. Now to apply law of reflection, you know, this is the normal, this is the incident ray, so this is angle of incidence I. Now this is the reflected ray, this is the normal, this is angle of reflection R. And we know that angle I equal to angle R. So this is theta, this is again theta. Now look at the, follow my fingers. I'll come like this in this manner. Again I'll come like this in this manner. This is. So if this is theta, this is again theta. That's what I have drawn here. If you are coming like this, dotted line, again dotted line blue, again dotted line blue, you have this is theta, this is theta. So the two blues gives theta and theta. Similarly, if these two are 2 theta, combine these two, I and R combine, then you will get it as 2 theta. So for the orange shaded dotted lines, you can see coming over magenta, again coming over magenta, then going to white. Means if this is theta, this is again 2 theta. So this is theta plus theta 2 theta, here again 2 theta. So the Z lines, this is the how I took the Z lines, so that is 2 theta. Clear? Now one more thing. I need to make tan theta. From the two angles, I need to make tan theta and tan 2 theta. And you know tan 2 theta or theta, whatever it is, ratio of the sides. So to make this a triangle, I am dropping a perpendicular from N to M so that this angle is 90. So right angle triangle M is 90 degree. So the two triangles CMN and also FMN both are right angle triangles. Two triangles we are considering once again CMN, that is this. The other one FMN, both are right angle triangles. Of those right angle triangles, tan theta can be written as opposite by adjacent side. Both of them has opposite as MN or NM, whatever it is, opposite side. Suppose NM. Divided by adjacent sides will be different. For theta it will be MC. For 2 theta it will be MF. This is for 2 theta. This is for theta. Clear? Now the most important thing is, this is the method of solution NCERT, hence I use this method. Even if we don't have all these derivations, in a single line you can say R equal to 2F. Just in a line I can show that. Now suppose it is very clearly specified all the rays has to be paraxial rays. What do you mean by saying paraxial rays? Falling close to P of the mirror. What is P? Pole of the mirror. Make small angles with principal axis. That's what I am going to show you, meaning theta is small. Now come along. If this is the paraxial ray, suppose the magenta line is coming closer and closer and closer and closer and closer and closer to the principal axis. At the time, what happens for the normal also? I draw a normal at the point of incidence. So when the magenta line is walking along in this manner, my normal also has to walk in this manner, this manner, this manner. It comes along very close to the point P. While it reaches P, what happens to M? M is again walking. When N is walking towards P, M is also walking towards P, and M and P comes very close to each other, so that at the place of M, wherever you write M, you can replace it with P itself. That's a thing. And moreover, if that's a thing, from the figure you know this is theta, this is theta. Clear? If these two are theta, this is an isosceles triangle. So what about CF and FN? These two sides. One is CF, hope it is clear. One is CF, other is CN. What happens to CN? If N is coming close to P, M is very close to P, the line FN moves like this. It moves like this. Finally it falls at the point P. So FP. So you will have, instead of FN, you will have FP. What is FP? Focal length F. What is this? It is same as CF. CF is CF, whatever be the value of CF, the same will be the value of FP when N comes close to P. So FP same as CF means what? If this is F, this has to be F, means F plus F will be R. That's enough. But this is how it describes in NCERT, hence I took the same pattern. So we'll come back. So we have made all the M's as P. All the M's can be replaced by P. What's the condition? For theta small. Clear? Now, so M is close to P. So you will have wherever M, you can use it as PC and PF. The other values it is cancelling. So I didn't write. So instead of NM, you have NP, NM, NP. NP, NP cancels. Because what is 2 theta? 2 theta is simply twice theta. Okay? 2 times theta. Therefore, 1 by PF. What is PF? F. What is PC? R. So substitute 1 by F is equal to 2 by R. Cross multiply. R is equal to 2f. So what is the answer? R equal to 2f. So it's very simple relation giving R and F. It's very clear. This is R, this is F. Exactly the half. So whenever you draw the ray diagram, first you have to mark the point C, then the pole, half of it. At the midpoint, mark the point F. So bear in mind, first C, then P, midway F. Clear? Okay. Hope it is clear. Once this is clear, and although also the image formation rules, it's very easy for us to jump to mirror formula. So next video will be on mirror formula. Hope everything is clear. If you have any queries or comments, please put in the comment box. For sure I will be answering. Thank you for listening.